Let's move on to slightly more difficult questions. I'm going to go a bit out of order. This is number 4, and then I'm going to go back to number 3. Let's do number 4. Here we have absolute value of x plus 5 equals 0. The general strategy is exactly the same. We're going to go ahead and we're going to solve the two equations that result, one of which results if we just assume x plus 5 is positive, and we can take it out of its absolute value brackets. Let's go ahead and solve that one then. If we solve that one, it's x plus 10 equals 0, or x is equal to negative 10. Well, does that work? Let's plug it in. Negative 10 plus 5 is negative 5, the absolute value of which is positive 5, plus 5 does not equal to 0. Okay, this is our first example of a solution that we find that doesn't work. Okay, we assume that, well, maybe x plus 5 is positive, and if it is, this ought to be true, and x equals negative 10 might work. But let's think about this a moment. Why doesn't this approach always give us true solutions? The right side of the equation is 0. The left side of the equation is 5 plus something. This something is an absolute value. An absolute value is either 0 or positive. It can never be negative. Think about that for a moment. 5 plus something that's either 0 or positive. Could that ever equal to 0? Well, 5 plus, the only way to get 5 plus something equal to 0 is to add something negative to 5. Could x plus 5 absolute value ever be negative? No, because it's an absolute value. So this gives us pause to thought. In fact, pause for thought. In fact, not only would this solution, if x plus 5 were positive, not be true, but even if we made this x plus 5 a negative, it still wouldn't and couldn't possibly be a solution, because nothing plus 5 could equal to 0 unless that something were negative. Well, just to complete that thought, let's go ahead and try it. Let's make negative x plus 5 equal to 0. Well, distributing the negative sign, that would give us negative x minus 5 plus 5 equal to 0. That would give us negative x equals 0, or x equals 0. Well, nope, doesn't work, because 0 plus 5 is 5, absolute value of 5 is 5, plus 5 is 10. So neither of these candidate solutions work, and in fact, in this case, there is no solution, for the reasons we already discussed. Let's go back to number 3. Now, number 3, this equation, for the first time, we're seeing an x that's not in an absolute value sign. But this does not change our general approach. So again, we write down 2x minus 1, absolute value, minus x equals 5. And what we're going to do is we're going to assume the cases where 2x minus 1 could be a positive value, or where it could be a negative value. Okay? So if it were a positive value, we could just take it out of its absolute value bracket and just say 2x minus 1 minus x equals 5 and solve that. Well, 2x minus x is x. So we have x minus 1 equals 5, or x equals 6. Let's take a look. Does that work? Well, x equals 6. 2 times 6 is 12. Minus 1 is 11. Minus 6, well, 11 minus 6 is equal to 5. So that does work. Okay, you should plug it in, make sure that you agree. The second possibility is that 2x minus 1 is a negative, in which case we want to do negative 2x minus 1. Notice we're putting the negative just in front of the 2x minus 1, because that is the term that could be negative, could be positive, minus x equals 5. So that is the only term we're putting a negative in front of. Let's go ahead and solve this and see if that solution might work. Distributing the negative sign, negative 2x plus 1 minus x equals 5. Let's combine like terms and simplify. We get negative 3x plus 1 equals 5. Negative 3x equals 4. Or x is equal to negative 4/3. Okay, that's sufficiently complicated that I think I'm going to write out the substitution. I can't quite do that one in my head too comfortably. So let's see if it works. The absolute value of negative 4/3 times 2 minus 1 minus And in this case, we don't have the absolute value, just minus negative 4/3 equal 5. Let's see if that is true. So 2 times negative 4/3 is negative 8/3 minus 1. Minus a negative 4/3 is plus 4/3 equals 5. Okay, let's keep on going. Negative 8/3 minus 1. Well, 1 is 3/3, so this would be negative 11/3, right? Negative 11/3 absolute value plus 4/3 equals 5. Well, what is the absolute value of 11/3? It would be negative 11/3 would just be 11/3. So 11/3 plus 4/3 equals 5. Is that true? 11/4 is 15/3? Yes, it works. So therefore, negative 4/3, x equals negative 4/3 is also a solution. So here's an example where, once again, both of the candidate solutions are actually true solutions.